Here we are with rational expressions and functions 4.9, not 4.8. Somehow that didn't get changed. So I'm not sure what's going on there. Alright, so we're going to kind of start off with a few different types of equations. Just kind of a review of some of them that we probably haven't seen for a while. So like this, absolute value equations. Remember, when you're solving an absolute value, which is not necessarily part of what we're doing right now, but just kind of a quick reminder, because absolute values take positives and negatives and makes them the same thing, we use that idea. You get rid of the absolute value and you make one of the answers positive, and then you do it again with one of the answers negative, kind of taking into account those both possibilities. Then we solve. 4n equals 2, divide by 4, and n can equal 2/4, which is 1/2. Or, go in the opposite way, 4n equals 0, divide by 4, and n equals 1/2, or 0. So there are two possibilities there. Okay, now remember, when we're dealing with these guys, whatever they're called, exponentials, you look for the same base. If you have the same base, then we know their exponents have to be the same, so you get rid of the bases, and you just deal with the exponents. If the bases weren't the same, we'd have to search until we could get the same base. So then I could add 3r, giving me 2 equals 5r, divide by 5, and we get 2/5 equals r. Okay, the logs, same idea. If we have the same logs, we just get rid of those and we're left with what's inside the parentheses, and that's what we solve. So let's add a 3n here. That would give me negative 2 plus 3 is 1n, subtract a 7, negative 10 minus 17 is 17, so n equals negative 17. Okay, so just kind of a quick review on some of those. Now, let's start talking about radicals. Okay, dealing with radical equations. So, you've got to remember that basically when you're solving a radical equation, you are trying to get it so that you can square or cube or take to the fourth, whatever the radical is. In all these cases, I think they're just squares, square roots. You want to get it so you can take the power, because that's what's going to get rid of them. Okay. Now, we're mainly dealing with the square root, so we're going to square them. So if we're talking about this, the first step in solving these is to get the radical alone. So if I look at number 4, I've already got it alone. If I look at number 5, it's already alone. 7, there's 2 of them, but they're alone. There's nothing else. Okay? Like here's where something wouldn't be part of it, and we'd have to deal with it, or this, before we could do it. Okay? Once you get the radical alone, square the equation, and then the third step is solve for the variable, or slove, I guess it would be, slove for variable. Instead of solving, we're sloving. So let's take a look at what that looks like. So 5, let's jump on that one first. Square root of p equals 2. So I square both sides, because if I do it to one side of the equation, I do it to the other. Those cancel, I'm left with p equals 2 squared, which is 4. Then it asks us to check for extraneous solutions. Usually if you're only given one answer, you don't have to, but you've got to remember that idea that when we square things, it makes negatives positive, and so that's kind of the idea we're thinking here when we deal with this. Okay, so there's sometimes you can come up with an answer that actually doesn't work. This one does, because the square root of 4 is 2. It's positive 2 or negative 2, so it works. Okay, 4, same idea, square these. 4 squared is 16 equals 2a, divide by 2, and we get a equals a. Okay, number 6, they're both alone, so we square both of them, giving us 2b minus 1 equals b plus 1. So we can, because those undid things, so then we just simplify, subtract b from both sides, giving us b minus 1 equals 1, add 1, and we get b equals 2. If I really needed to, I could go 2 plus 1, giving me the square root of 3 on the right side. 2 times 2 is 4, minus 1 is 3. Square root of 3 is going to be equal to square root of 3, so it will work out. So I know that's a correct answer. Typically, though, if you only get to one number, that's most likely going to be your answer. 7, same idea. Square these. So I get b over 4. b divided by 4 equals 3b minus 44. Okay, first thing I want to do is multiply everything by 4. Get rid of that fraction. Okay, just like those rationals, right? Getting rid of the rationals, the fractions. 4 times 3 is 12b. 4 times 44 is a number that I don't readily have in my mind, but we can solve it. 176. So subtract 12b, and we get negative 11b equals negative 176. And as luck would have it, if we divide by negative 11, we end up with b equals positive 16. So if I really wanted to, I could check that. 16 divided by 4 is 4. Square root of 4 is 2. Right? 3 times 16 would be 18, 48. 48 minus 44 is square root of 4, which is 2. So yeah, it works. So that is an correct answer. Alright? So, not too bad, right? Moving right along with these. So now let's see what we do in these situations. Okay, so we need to simplify and get the radical by itself. How do I do that? Get rid of that plus 2. So we subtract 2, giving me the square root of x over 2 equals 4 minus 2 is 2. Now I can square both sides. We end up with 4 equals x over 2 times both sides by 2, and we get x equals 8 for our answer. On number 9, it's 2 times the square root of p over 2, so I divide by 2, giving me the square root of p over 2 equals 3. 6 divided by 2 is 3. So now we can square them. And we end up with p over 2 equals 9 times by 2, and p equals 18. Okay. Now let's make them a little more complex here. Now this is where we add the difficulty level. Okay. So first thing I need to do is get that radical by itself. So I'm going to add m to both sides. Problem is, negative 2 plus m, can't combine them, so it's like m minus 2. So we get 3m minus 6 under the radical equals m. Now when I square it, I don't square them separately. I square them like this. Okay, which should key us into the fact that we're going to deal with a quadratic here. On the left side, though, we simplify. So m minus 2 squared is like m minus 2 times m minus 2. Okay, so we can just multiply that out. M squared, negative 2m, negative 2m, so that's negative 4m. Negative 2 times negative 2 is positive 4. Then we get all the same thing on the things on the same side. So subtracting 3m and adding 6. So that gives us 0, because those both canceled, equals m squared minus 7m plus 10. Now the reason we want to do this is because now we're reaching back to last year when we had to solve a quadratic. See, now this is going to give us 2 answers. So here is where we really have to worry about those extraneous solutions. Okay? So if we need to, you can do the box method, or you can just do it in your head if you're awesome like me. And we get factors of 10, 2 and 5, negative 2 and 5. They give us 7. Okay, and here's why I say do it in your head. If you can figure that out, you know it's going to look like this, m minus 2, m minus 5, because it's only m squared. If that were like 1 or 5 or some other number, then the box method helps. But here, we just basically redo everything and say pull an m out, pull a negative 2 out, pull an m out, pull a negative 5 out. See, did the same thing much quicker. So that equals 0, so I set them equal to 0 separately. kind of like we did with the graphing. And we solve. So 2 is m, and 5 is also m. So those are our two possibilities, 2 and 5. So let's write those up there. So 2 and 5. So now we got to double check them. So let's put 2 in there for all the m's and see if it works out. So we could add 2 to both sides, right? We get the square root of 3 times 2 minus 6 equals 0. 3 times 2 is 6. 6 minus 6 is 0. Square root of 0 is still 0. So that one works out, right? So 2 is a possibility. Let's try 5. You could have two possibilities, but you've got to check them, because if one of these doesn't work and you put it down as your answer, you're out of luck. So 3 times 5 is 15. 15 minus 6 is 9. Square root of 9 is 3. So negative 5 plus 3 equals negative 2. Add 5 to both sides. Actually, why am I doing that? I'm not solving for 3. That would be, and even if you thought about negative 5 minus 3, because it's a plus or minus 3 with the square root of 9, right? Either one of these isn't going to get, well, the positive 3 will get us there, won't it? That one wouldn't, but this one would. Negative 5 plus 3 is negative 2. So does negative 2 equal 2? So, because that positive version, and that's kind of what you want to think of, just think of the positive versions there. So the positive 3, let's not worry about the plus or minus 3 with the square root of 9. Negative 5 plus 3 is negative 2, so it still works out, right? So they're both possible answers. They both work. Okay, now let's try number 11. So we've already got the radical by itself, so we start by squaring. So I've got 3 minus p equals, now p minus 3 squared is like p minus 3 times p minus 3. So we get p squared minus 3p minus 3p, combine those like terms, minus 6p plus 9. 3 times negative 3 times negative 3. So we add a p, giving us 3 equals p squared minus 5p plus 9. Then subtract a 3. So we get 0 equals p squared minus 5p plus 6. So now we factor it, and we get p minus, let's see, we need a negative 5, so p minus 6 and p plus 1, because negative 6 and, no, that's not going to work, is it? Let's make sure we did everything right. Negative 6, we had a minus p, we added a p, negative 5, had a 9, had a 3, 9 minus 3 would give us 6. Different factors, right? I always forget these factors with 6. What about 2 and 3? Times together, they make 6. Added together, they could make negative 5 and multiply positive 6. So, we know p minus 2 is equal to 0, so add 2. Positive 2 equals p. We know that 0 is equal to p minus 3, so we add 3. So we get a 3 for p. So we can check 2 and 3 for our answers. So take our equation, and let's do this in a different color. 3 minus 2 equals 2 minus 3. Okay, because we don't need those squares, right? 3 minus 2 is 1. Square root of 1 is 1. 2 minus 3 is negative 1. Is 1 equal to negative 1? No, that's not an answer. Now let's try with 3. 3 minus 3 equals 3 minus 3. Square root of 3 minus 3 is the square root of 0, which is 0. 3 minus 3 is 0. Does that work out? Yes. So here 2 would be our extraneous solution and wouldn't work. Okay. So 3 would be our only answer on this one. Okay, number 12. Okay, now we're getting even super crazier. So, follow along here. with this one because we're going to go for a ride. I've got one of these by itself, so I'm going to square these. Okay, so I get negative 7 minus 4x equals this. Now I'm going to square that. Square root of 8 minus x plus 1 times square root of 8 minus x plus 1. Okay, so square root of 8 minus x times square root of 8 minus x gets rid of our radicals, and we're left with 8 minus x plus square root of 8 minus x times 1 plus square root of 8 minus x times 1, which is square root of 8 minus x. Then 1 times 1 is 1. Now we treat that like as if they're like terms, so we get 2 square roots of 8 minus x here. This 8 and this 1 can give us plus 9. And we have this negative x out front. Okay? And that is all equal to that negative 7 minus 4x. So now we try to get this radical by itself. Okay? So subtract 9, which would give us negative 16. Add x, which would give us minus 3x equals 2 root 8 minus x. Okay, now we got to get rid of this 2, so we divide everything by 2. So we end up with negative 8 minus, what is that, 1.5? We'll just write that. 1.5x equals square root of 8 minus x. Now we get to square things again. See how lovely this one is? So 8 minus x on the right. Then we should have, know that we're going to have to multiply that. So negative 8 times negative 8 would be a positive 16. Well, actually, no, positive 64. Okay. Negative 8 times negative 1.5 twice. So negative 8 times negative 1.5 would be a positive 12x. We did it twice, so another 12x. Then negative 1.5 times negative 1.5 would give us, what is that, 5, 2, 7, 5, 1, 5, 2, 2, and then 2 of these, so 2.25 plus 2. Wow, having troubles here. Plus 2.25. Okay. Whew, we're getting there eventually. So we've got 64 and 2.25. So 66.25 plus 24x equals 8 minus x. So we could add an x, give us 25x equals, subtract 66.25. And we would get 58.25. And we divide by 25. And I know this feels like I'm getting something wrong here, but we're going to call it good. Dang it, found my mistake. That should be x squared, shouldn't it? Ugly, 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 ugly. But this is sometimes a process. Okay? So subtract 64, right? Actually, we want to probably get everything on the left side. So subtract 8, and we get 56. Add an x, we get 25x. So 2.25x squared plus 25x plus 56 equals 0. Now, this is when you use the quadratic formula, because this is an ugly one to try to just do by hand. So that quadratic formula, remember, this is like A, B, and C. It's the opposite of B plus or minus square root of B squared minus 4 times A times C over 2 times A. And for something like this, really what you end up wanting to do is just type it in a calculator. The whole thing. And another thing you could do actually is to graph this and find where it crosses the x-intercept. I just did that, and you can see that our answers would be negative 8 and negative 3.111. okay, which we need to go back, plug in here to decide which ones work and which ones do not work, okay. I can pretty much take a guess now and say that yeah, we'll see which ones work. Let's take a look at that. So let's clear that out. So we have -8 and -3.111. Okay, let's see which one gives us an answer. Now, when we take a look at this and plug them in, okay, -3 times 4 would be in the 12, so it would be -7 minus 12 point something something. Whereas this one would be 8 minus a negative would only be 11. So right there you can see they're not going to come up to be the same, so I know that that's not going to be an answer. Let's take a look at 8. So -7 minus 4 times -8. So negative and negative would be a positive 32. -7 plus 32 would be 25. Square root of 25 is 5. 8 minus a -8 would be 16. Square root of 16 is 4. Plus that 1 would give us 5 on the right side. So there's our answer. A lot of work to get there, wasn't it? Alright, let's keep moving. So I'm not going to be checking any more of the answers, just for sake of time. I want to make sure we finish all these. So we start off by squaring. That gives us 1 minus n. And then on the other side, 1 minus square root of 2 minus n times 1 minus square root of 2 minus n. 1 times 1 is 1. 1 times negative, square root of 2 minus n. 1 times negative, so same thing again. And then you multiply those last two together, and you get us positive 2 minus n. Okay, that combines, giving us 1 minus 2 square roots of 2 minus n plus 2 minus n equals 1 minus n. We bring that part down. So 1 plus 2 is 3. Subtract 3 from both sides. We get a positive 2 on the right. Add an n. We get a positive 2n equals what's left over? -2 square roots of 2 minus n. Divide by -2. Those cancel. Square root of 2 minus n. 2 and 2 and 2 all cancel, so we're left with -1 minus n. Now we square those. End up with 2 minus n. Oh, I forgot to erase that graph, didn't I? Equals 1 times 1 would give us positive 1. -1 times -n would give us positive 1n twice, because we're squaring it. -n times -n would be a positive n squared. So 2 minus n equals 1 plus 2n plus n squared. Add n to both sides. Subtract 2. We get 0 equals -1 plus 3n plus n squared. Okay. Then we would factor this, right? N squared plus 3n minus 1. Factors of -1 that add up to 3, we would need to use the Pythagorean theorem, or not Pythagorean theorem, the, whatchamacallit, why can't I think of it, quadratic formula. So plus or minus, opposite b, plus or minus square root of b squared minus 4 times a times c over 2a. This one might be simple enough to do by hand. So -3 plus or minus square root of 3 squared would be 9, minus 4 times 1 times -1, so it would be 4 times 1 times -1 over 2 times 1. So we'd get -3 plus or minus square root of 9 plus 4, which would be square root of 13. -3 plus or minus the square root of 13 over 2. I could use a calculator to figure out exactly what decimal that is, but I'm calling that good for now. Okay? Alright, that was a lot of those problems, guys, and I am definitely running out of time, so don't do 14, don't do 15. Okay? Let's say, We'll do 16 and 17. Don't do 18 and 19. Now we can do 20 and 21. So remember on these ones, okay, let's simplify that. That would be n minus 8 times n minus 1. So that would work for this one, so that's what we're going to multiply everything by. We're going to times everything by n minus 8 times n minus 1. Now by doing that, these two are definitely going to cancel completely, right? Because that's what they are. So we get 2 equals 1. On this side, when we multiply by it, n minus 8 times n minus 1, we cancel out the n minus 1's. We're left with n minus 8 times 1, so n minus 8. So simplify to n minus 9 equals 2, add 9, and we get n equals 11. Which then, we plug in that, is that going to make it 0? Nope. Plug it into those, is that going to make it 0? Nope. So it's our answer. Okay, then on 17, we take a look at these ones. Now let's simplify this. That gives us v times v minus 3. So that's the same as this piece. So I'm going to multiply every single piece here by v times v minus 3. Okay, v times v minus 3. So because that and that is the same, we get rid of that whole one, so we're left with 2 on the left. On the far right, they completely cancel, so we get plus 1. In the middle, only the v minus 3 cancels, so we're left with 3 times v, or 3v minus 1. We get 1 equals 3v, divide by 3, and 1/3 equals v. Okay, which if we look at those and plug them in, none of them become 0, so that's our answer. So that's what you do on 18 and 19, but don't worry about doing those ones. Same with don't worry about doing those two. Give you a little break, that was a lot of work. So now solve each equation by factoring. So basically we're just getting them all on the same side. Add 5k. So we get plus 5k minus 6. Factors of equals 0. Factors of negative 6 that equal positive 5. Now negative 6 could be 6 and negative 1. Yeah. So k plus 6, k minus 1 equals 0. Set them separately equal to 0. A lot of similar stuff we've been doing. So k equals 1 and k equals negative 6. So there's our two answers. Okay, on that last one, number 21, same idea, add 3n. We get n squared plus 3n minus 40 equals 0. Okay, factors of 40 that would add up to positive 3. Well, 40 is 4 and 10, nope. 2 and 20, no. 5 and 8, yeah, if the 5 is negative. So n minus 5, n plus 8 equals 0. Separately set them equal to 0 and solve. So we end up with positive 5 for n and negative 8. And those are our two answers. So there we go, guys. Got all our stuff done, and we can call that good now, right? Just going through, making sure we don't do those ones. Okay? Alright, we are done.